Welcome to the lecture entitled Scientific Explanation, Epistemological Issues. I'm Andrew Chapman. In this lecture, we'll discuss 8 topics. 1. How to investigate the nature of scientific explanation. 2. Why epistemology matters. 3. Empiricism and Rationalism. 4. Natural laws, accidental regularities, and explanation. 5. Empiricism and natural laws. 6. Empiricism and causation. 7. Empiricism and mathematics. And 8. The falsity of empiricism and the goals of contemporary epistemology. In investigating the nature of scientific explanation, it's important to notice that most people take science to offer a particular sort of explanation. There's good reason to think that one of the things that separates different explanatory disciplines, that is, disciplines that give explanations, from one another, is the sorts of explanations given. Thus, the sort of explanation given by an explanatory discipline can serve to demarcate that discipline from other explanatory disciplines. Even further, however, there's good reason to think, and most scientists certainly do think, that the explanations given by science within its particular domain, namely the domain of natural phenomena, are better than competing explanations given by non-scientific disciplines. Thus, science claims a sort of priority over explanations of natural phenomena, since science claims its explanations are the best ones available of natural phenomena. An investigation of scientific explanation is an inquiry into the nature or essence of scientific explanation. In order to search for this nature or essence, we should start by analyzing the notion of scientific explanation. Such an analysis of the notion of scientific explanation will result in an explication of explanation. An explication is a completed analysis of a thing, and explications make explicit the nature of that thing by providing the necessary and sufficient conditions for something to count as that thing. Thus, when searching for the nature or essence of scientific explanation, we should attempt an explication of the notion of scientific explanation, and explication will result in the necessary and sufficient conditions for something to count as a scientific explanation. Epistemology is the philosophical subdiscipline that studies the nature of knowledge and justification. An epistemology is a theory concerning whether and how knowledge and justification are possible. Even though the goal of explanation is generally concerned with seeing the world objectively, explanations themselves are human-centered things. It's humans that request, provide, understand, and employ explanations. Accordingly, any investigation into the nature of scientific explanation either is or will require epistemological work. Whichever epistemology, that is, whichever theory concerning knowledge and justification, we think is true will dictate which pictures of explanation are plausible and which are not. If our epistemology holds that knowledge is only possible in some way, call it way X, and not possible in some other way, call it way Y, then we shouldn't adopt a picture of explanation in which explanation relies on our having knowledge in way Y, the way our epistemology says is impossible. Empiricism is the epistemological theory that justification and knowledge are only possible via sensory experience. That is, there is no non-sensory justification or knowledge. Another way of saying this is that all justification and knowledge is a posteriori, and no justification or knowledge is a priori. It's important to recognize that empiricism is not the position that the senses are important to justification or knowledge. A number of popular writers have gotten very confused and used these terms unclearly and somewhat incoherently, and have misunderstood empiricism and thought that empiricism is just the position that the senses are important. No, it's much more than that. It's the position that knowledge and justification are only possible via the senses. Rationalism, on the other hand, is the epistemological theory that justification and knowledge are at least sometimes possible via non-sensory sources. That is, it is possible for there to be non-sensory justification or knowledge. Another way of saying this, not all justification and knowledge are a posteriori. It's possible for there to be justification and knowledge that are a priori. And rationalism is not the position that the senses are unimportant for justification or knowledge. The empiricism-rationalism distinction is mutually exclusive, meaning there's no possible hybrid position of the two, and jointly exhaustive, meaning that there's no possible third position outside of empiricism and rationalism. Natural laws are regularities that hold with necessity. For example, gravity is a natural law. Taking our experience on Earth just for simplicity's sake, all unsupported bodies fall. That's the regularity, and the fact that they fall couldn't have been otherwise. It's not as though gravity might not have held in specific cases. That part's the necessity. Contrast with this, accidental regularities. Accidental regularities are regularities that hold contingently, that is, without necessity, merely accidentally, that might not have held. For example, the fact that there are no 1,000-pound plus cats is an accidental regularity. All cats weigh less than 1,000 pounds, that's the regularity, but the fact that there are not 1,000-pound plus cats could have been otherwise. It's not as though it's impossible for a cat to weigh that much, it's just that in fact there have never been cats that do weigh that much. That's the contingency. So the difference between natural laws and accidental regularities is this. Natural laws hold with necessity, while accidental regularities do not. Natural laws have traditionally played an important role in scientific explanation. For example, imagine that you see a broken vase on the floor and you ask me why the vase is broken. I might reply that I hit the vase with a baseball and that due to gravity and the brittleness of the vase and the hardness of the floor, the vase broke. Citing gravity and brittleness and hardness is citing laws. Laws tell you what had to happen given certain initial or boundary conditions. If you know that my baseball hit the vase, then you'll be able to predict that the vase would have broken. And since prediction and explanation are two sides of the same coin, your ability to predict on your part is also an ability to explain why the vase is broken. Accidental regularities don't work in the same way in terms of prediction, however. If I ask you why the cat in my kitchen weighs less than 1,000 pounds, telling me that there has never been a cat that weighs more than 1,000 pounds explains nothing to me. All it does is tell me what has happened in the past, but it doesn't tell me why anything has happened. Accidental regularities can't predict. All they can do is list what has in fact happened, and thus accidental regularities can't explain. Imagine that you observe some event happen over and over again in exactly the same way. Every time you observe an event of that kind, it looks exactly the same. Now, how can you tell whether the event is an instance of a natural law or, instead, a mere accidental regularity? What is the observable difference between a natural law and an accidental regularity? In what ways is a natural law empirically different from an accidental regularity? Of course, there isn't any observable difference between the two. The difference between a natural law and an accidental regularity comes in terms of necessity. But we can never observe whether something could have been different. All observation ever tells us about is what is actually happening, not about what could have or couldn't have happened. Thus, empiricism can't make sense of our knowledge of the difference between natural laws and accidental regularities. And if natural laws are required for explanation, then empiricism will be an unacceptable epistemology for giving scientific explanations and for practicing science more generally. Causation has traditionally been taken to be an important component of scientific explanation. The thought is that citing an event's cause is important or even sufficient for explaining that event. Causation is a connection that holds between two events. One, the cause, which is temporally first, and the other, the effect, which is temporally second. Not all events that occur one after the other are instances of causation, however. For example, suppose that the school day begins in Moscow and 1 second later I wake up in the United States to start my day. These are sequential events, but the former didn't cause the latter. However, what does causation look like? Can we see, smell, hear, taste, or feel causation? Now, of course, we might be able to see, smell, hear, taste, or feel events, but causation isn't the events, it's the glue between the events. Philosopher David Hume noted that empirically, what we call instances of causation are merely constant conjunctions of events. We never experience, we never see the causation. Thus, Empiricism can't make sense of our knowledge of the existence of causal relationships, and if causation is necessary for explanation, then empiricism will be an unacceptable epistemology for giving scientific explanations and for practicing science more generally. Mathematics is an essential component of science. But how do we know that, for example, 2 plus 2 equals 4? Certainly, you might put two things next to two other things and then count the lot of them, 4. But knowing that 2 plus 2 equals 4 entails knowing that always, even in unobserved cases, even in the remote past and the distant future, 2 plus 2 will equal 4. Recognizing this, logical positivists, the archetypical empiricist philosophers, claimed that mathematical truths were merely stipulated, and that, for example, 2 plus 2 equals 4, not because 2 plus 2 actually equals 4, but because we defined the relevant terms the way that we did. Thus, said the logical positivists, mathematical knowledge is just knowledge of memorized definitions, and this is something that's possible according to empiricism. However, in the early 20th century, the failure of Bertrand Russell and Alfred North Whitehead to reduce mathematics to logic in their abandoned Principia Mathematica, and discoveries by Kurt Gödel that it's impossible for a logical system that is both consistent and complete to represent arithmetic, and Immanuel Kant had actually proven that mathematics and logic were distinct 150 years prior, and essentially what Gödel was up to was recreating things that Kant had already recognized. These things showed that empiricism could not possibly make sense of mathematical knowledge. Thus, empiricism could not possibly be the epistemology of any science that required or used mathematics, namely all science. One of science's main claims to fame is that it is objective. The conclusions that science produces can be trusted as descriptions of the way the world actually works, apart from anyone's mere subjective perspective. A traditional claim about what guarantees science's objectivity is that science appeals to empirical evidence, and that the empirical is mind-independent, intersubjectively checkable, and about as objective as possible. Some people worry that if we give up on empiricism, we would give up on objectivity. Once we allow even the tiniest bit of non-empirical evidence into our scientific theorizing, the thought goes, we now have to adjudicate claims concerning which of two pieces of non-empirical evidence is more objective or more scientific. The non-empirical has also traditionally been the haven for pseudoscience. When the pseudoscientist can't justify some dubious claim, we can always just appeal to the non-empirical. These worries about what happens if we give up on empiricism are well taken. However, the fact that some bad things might be possible if empiricism is false doesn't make empiricism true. As we've seen, empiricism can't account for our knowledge of natural laws, causation, or mathematics, all things that have been taken traditionally to be part of the scientific enterprise. Even further, there are a number of arguments, again dating back to Kant, that show that empiricism doesn't just fail us in science. Empiricism is actually self-undermining and therefore impossible. These arguments that empiricism is self-undermining are related to arguments against verificationism and the verifiability theory of meaning, showing that if you make something entirely empirical, it ends up undermining itself. Nearly all non-dogmatic contemporary epistemologists, thus, have abandoned empiricism. However, recall that our other epistemological option, rationalism, doesn't claim that empirical evidence is no good or that the empirical should be eschewed entirely. Rationalism is entirely consistent with and supportive of an epistemology that claims that empirical evidence ought to be appealed to as much as possible. Rationalism merely asserts that non-empirical justification and knowledge are at least sometimes possible. Of course, recognizing the falsity of empiricism and the truth of rationalism saddles us with an important epistemological task, namely determining how non-empirical evidence works and instituting epistemological standards to guard against false claims of justification and knowledge. And this is exactly what contemporary epistemologists and philosophers of science take as one of their central goals. In this lecture, we've examined 8 issues. 1. How to investigate the nature of scientific explanation. 2. Why epistemology matters. 3. Empiricism and rationalism. 4. Natural laws, accidental regularities, and explanation. 5. Empiricism and natural laws. 6. Empiricism and causation. 7. Empiricism and mathematics. And 8. The falsity of empiricism and the goals of contemporary epistemology. Thank you.